Hey guys, today we are going to be talking about what uniform motion problems are and how to solve them properly. So, what is uniform motion? Uniform motion is an object that travels at a constant speed and has an equal distance and time interval. Now, that means it's constant, it never changes speed, at a consistent speed, and the distance and time all make sense. That can be represented with the equation d equals rt. That's how you solve for distance. If you want to solve for rate would equal d over t. If you want to solve for time, you can set up t over r. This is basic literal equations. So an example of uniform motion is that I run at 6 miles per hour for 2 minutes. That is very reasonable to do that. You can run 6 miles per hour for 2 minutes. What an example is not uniform motion is that I run 6 miles per hour for a triathlon. Now, triathlons are approximately 32 miles. That's pretty much impossible. You're slowly going to decrease in speed. If you draw that on a graph, you're going to start at 6 miles. You're doing good, but eventually you're going to start to drop down. And within the time, it's pretty much impossible to keep a consistent rate on a triathlon. Let's move on. Okay, so there's 4 types of scenarios while dealing with uniform motion. There's when you're going towards each other, away from each other, going the same direction, or when you get a head start. Okay. These are the 4 main ones. Okay, let's look at the towards scenario. Jack and Jill go to a house. Jack rides his bicycle at 6 miles per hour and Jill walks at 3 miles per hour. Jack rides his bicycle for 20 minutes and Jill walks for an hour. What is their total distance? So we can draw the house. Always draw a model. We can say that this is Jack. This is Jill. So Jack rides his bike for 6 miles per hour. Jill is 3 miles per hour. He rides for 20 minutes. She walks for 1 hour. We're looking for this distance, D. So what we can do, we can set up a chart. We can say Jack could be A and Jill can be B. So we're going to set it up like this, RTD. So the rate, we know what the rate is. 6 miles per hour, 3 miles per hour. Always make sure to write your units down so you know what kind of unit you're talking about. Jack travels for 20 minutes, but that's not an hour. 20 minutes is a third of an hour. So instead, we would put 1/3. Jill travels for 1 hour. That's fine. Next, to solve for distance, we multiply. So 6 times a third is 2. 3 times 1 is 3. What we do to find their total distance is we just add them. So the total distance covered by them is 5 miles combined. That's their total distance combined. We find each of their distance, but we combine them because it's asking us for the total distance. Okay, now if you're going away, 2 birds decide to migrate. One bird travels north at 36 miles per hour and the other bird travels south at 30 miles per hour. They both fly for 15 minutes. What is the total distance covered? So, we can draw out the birds. So one goes south, 30 miles per hour. One goes north, 36 miles per hour. and they both go for 15 minutes. We want to find their distance. Once again, the total distance. We can set up a chart once again. You can label this one A, this one B. Okay, so A, B, R, T, D. It's really helpful to set up a chart so you know what you're doing. So we have 36 and 30. This is miles per hour. And now that means our time has to be in hours. 15 minutes is a fourth of an hour. So let's put that. So 36 times 1/4 is 9. 30 times 1/4 is 7.5. And then what we're going to do, we're going to add them once again. That's going to give us 16.5 miles. Okay, now let's look at the scenario when they're going the same direction. James and Riley decide to go to the ice cream parlor. They live together. So that's a key point. They live together. James rides his bicycle at 8 miles per hour, and Riley walks at 4 miles per hour. When James arrives at the parlor, Riley is half a mile away from the parlor. What is the distance from the house to the parlor? So, they both start at the same place, the house. So this one's James. This one is Riley. Okay. So James, 8 miles per hour. Okay, let's say the parlor is this little rectangle. Riley, 4 miles per hour. Okay, she's half a mile there. So, this one's a confusing one because you're not given a time. You're trying to solve for a distance. You're trying to solve for this whole distance. How far James traveled. Okay, sorry if I said Jack. So, if we want to find how far is the two places, we can start up the equation. So, since we're going to solve for time first, so we can say AT, that's our distance, AT, equals 4T plus a half. 4T is our distance for Riley, but half is that extra bit. So what we're going to do, we're going to subtract 4T equals half. Half divided by 4 is an eighth. So your time would take you half an eighth of an hour. Now that's just time. So what we're going to do now, we're going to input it. We're going to input it into here. And then what we're going to eventually get is 8 times 1/8, which is just going to give us 1 mile. That would be our answer. The last scenario. The tortoise and the hare, or it's a head start scenario. The tortoise and the hare have a race. The turtle goes at 2 miles per hour, gets a mile head start. The hare travels 36 miles per hour. When will the hare catch up to the tortoise? So we're solving for time. This is when. The next thing, that he gets a mile head start. So we're going to set this up the same way as we did with the other equation. So we're given two rates. So 36t, that's the total distance. 2t is this is the hare's distance. That's equal to 2t, the turtle's distance, plus a mile. So what we're going to do from there, we're going to say 34t equals 1. T equals 1 out of 34. 1/34 of an hour. So you gotta make sure what you're talking about. or it won't make much sense. And that's all for uniform motion. If you have any questions, leave them down in the comments below. And bye.